Alrighty, so we've got a new formula here, and that's the potential energy of two masses. If I've got a mass here and a mass here, call that one big M, that's one little m, right? And there's some distance r. Their potential energy is this. It's negative gmm over r. It's negative because, of course, we're talking about their potential energy with relative to infinity. And so bringing this mass in from infinity, actually, it's attracted to this other mass, and so we do negative work on it to bring it to this position, and that's why it's negative. Okay, the closer it gets, the farther down into that sheet of rubber that we get, right? So this mass is traversing farther and farther down, and this number becomes a bigger number the closer they get together. But it's negative. It's a negative potential, and this comes from that gravitational potential is. So this is potential energy. Okay, gravitational potential, that is the energy per kilogram, is minus g big M over r, and then if you just multiply that by mass, you get the actual potential energy in joules. Okay, so this is in joules. This is our energy actually in joules. This is also kinetic energy in joules. Okay, so on the gravity side, we get this beautiful thing, right? We get that the total energy of a system is 1/2 mv squared, right? If the little m is moving, right, plus minus g big M little m over r. Okay, so, and if the big M is moving, of course, we'd have a big 1/2 big mv squared, right? But this would be our total energy, right? Let's take a look at the electrical side here. We have the equivalent formula, and it comes from the electric potential is kq over r, right? And then remember that the potential energy is just Q times the electric potential energy. So if you just multiply both these by Q, right, then you get the actual potential energy in joules, right? So the difference is, right, this is in joules per coulomb, right? This potential energy is actually joules. This thing has the units of joules, actual energy, okay? And again, we could have if we had a moving charge, we'd have an energy of 1/2 mv squared plus, we could also have this thing, kq over r. Okay, now be very careful, right? This thing, if we have two positive charges, as is the default case, then yeah, this is a positive energy, right? If this is positive and that's positive, you have a positive energy. That is, to bring this thing in from infinity, you have to do positive work, and it has positive energy, okay? If they're both negative, the same case is true. I have to do positive work. They repel each other. So you don't want to ignore the minus signs in here, okay? If they're both positive, it's positive energy. Both negative, it's positive energy. If one is positive and one is negative, then this term becomes a negative term, because you have a positive times a negative is a negative. Okay, and then it becomes just like gravity. This thing is attracted to this, right, and vice versa. If this is negative and that's positive. So anyway, basically, to solve these problems, we're just going to set this equal to this, right? Okay, yeah. All right.